In this question, they are asking out of tertiary butyl alcohol and N-butanol, which one will undergo acid catalyzed dehydration faster and why? Yes. So, if you are comparing these two compounds, tertiary butyl alcohol will undergo faster reaction. Tertiary butyl alcohol. Okay, because tertiary butyl alcohol normally forms tertiary carbocation. Okay, so in case of N-butanol, they will form primary carbocation. So we know if you are comparing the stabilities of primary and tertiary carbocations are more stable than primary. That's why the dehydration reaction of tertiary butyl alcohol is more faster than normal butanol. Okay, so the next part of this question is, here some conversions are given as phenol is converting into salicylaldehyde. So how will you convert phenol into salicylaldehyde? Okay, so we are starting from phenol, that is benzene ring containing hydroxyl group. Okay, so this compound is treating with the CHCl3 in presence of sodium hydroxide. The product will be corresponding sodium salt, that is ONA will be here and the aldehyde group will be here. Okay, then in acidic medium, means in H plus medium, this compound will convert to corresponding salicylaldehyde. Salicylaldehyde means hydroxyl group should be there and CHO group should be there. This is the first conversion. Now, the second one is N-butyl chloride to tertiary butyl ethyl ether. So we are starting from CH3 thrice CCl, tertiary halogenoalkane, that is tertiary chloroalkane. Then treating with the aqueous sodium hydroxide. Then the product is corresponding tertiary alcohol. Now, this tertiary alcohol on reaction with sodium, they will produce CH3 thrice CONA, corresponding sodium salt. This one on reaction with the C2H5Cl, they will produce CH3 thrice COC2H5. That is tertiary butyl ethyl ether. This is the conversion. Now, next one, propene to propanol. Okay, so we are starting from propene, that is CH3, CH, double bond, CH2 on reaction with the diborane, that is B2H6 in presence of hydrogen peroxide in basic medium, they will produce corresponding propanol, that is CH3, CH2, CH2OH. This is the conversion. The OR question is, first one, give the mechanism for the formation of ethanol from ethene. Okay, so the first step is protonation of alkene to form the carbocation by electrophilic attack of hydronium ion. So we are starting from H2O. H2O on reaction with H plus ion, they will produce H3O plus ion, that is hydronium ion. Now we are taking the alkene. So any alkene you can take. So I am simply representing the alkene like this. Now this alkene on reaction with the hydronium ion, that is H3O plus. There is one lone pair on oxygen atom. Now what will happen? This double bond will take this hydrogen, then this is taking H plus ion. So these bonded electrons will move to the oxygen. So the bond pairs and the moving to the oxygen means the lone pairs of oxygen is replaced. So the product will be CH, and these are the already present. These two bonds are already present. So these two bonds I wrote. Now the carbon containing positive charge, that is the carbocation and the two bonds plus H2O. Now, in the second step, this carbocation formed in the first step, that is, this is one hydrogen and other two bonds are already there, and this carbocation will react with the next water molecule. On water molecule, there is a two lone pair of electrons. So, one lone pair of electron, using that, they will attract the carbon and they will produce one hydrogen is there, two bonds are there, and this is the two bonds, and here O, H, H. This is the water molecule and plus charge on oxygen. Now, the third step is deprotonation. So, this is not an alcohol. So, from this compound, if you do deprotonation, then only you will get the alcohol. So, we are taking that compound. This is the already added hydrogen. These two bonds are already there. Now, this is H2O. This is two bonds. Okay. Now, what will happen here? This is reacting with the water molecule again. So, water molecule using one of the lone pair of electron attack the H plus ion. Okay. So, when they attack this H plus ion, this bond will move on oxygen. So, the product will be hydrogen and these two bonds are there, C and OH. This is the final product, that is alcohol. Okay. Now, the second part is predict the reagent for carrying out the following conversion. First, we are converting phenol to benzoquinone. If you want to convert phenol to benzoquinone, the reagent you are using is potassium dichromate, that is K2Cr2O7 with sulfuric acid. Okay. For the second conversion, that is anisole to para-bromoanisole, we have to use bromine in acetic acid, that is CH3COOH. Third one, phenol to 2,4,6 tribromophenol. So we have to use bromine water or aqueous bromine. These are the reagents used for